Hello again, friends. In this video we're going to be working with our telescoping series once again. And like I explained in the last video, the telescoping series kind of works just like a telescope. So what you do is you expand, a telescope, expands out, and then you can contract it back down into a smaller size, right? So the telescoping series, they work in a similar way. We're going to take our series and we're going to expand it out into several partial sums. We're going to look at, our expanded out series, and we're going to see how it looks and if there's any terms that will magically cancel out along the way. And once we've made those cancellations, we'll be able to see that it all contracts down into a nice, easy series that we can take the limit of to determine whether or not it's convergent or divergent. So let's get started. So I have a series here written down, and the first thing we want to do is say, okay, is there any way that we can make this guy look a little nicer, a little easier to use, and that will help us identify terms that easily cancel in our telescoping series. So one way we can do this, right, since we have a division with our natural log here, we can rewrite this as the series from 1 to infinity, and we could do the natural log of n minus the natural log of n plus 1 by our logarithm rules. So now that we have this, let's start doing our work with our series. So the first thing we have to do is we have to expand out into some partial sums, right? So let's start off with a really simple one. Let's start off with n equals 1. When n equals 1, we're going to get the natural log of 1 minus the natural log of 2. Fix that there, sorry. 1 minus the natural log of 2, right? Those are parentheses, sorry, it's kind of messy. So now let's do it for when n equals 2. So this is our next partial sum, right? So we're going to have when n equals 1 still being added on. Oops, that's supposed to be minus the natural log of 2. Now we're going to add on when n equals 2. So the natural log of n in this part is going to be 2 minus the natural log of n plus 1 is going to be 3. So these are two partial sums. So now we're going to skip ahead and we're going to see if we can maybe find our pattern. So let's try when n equals 5. So we're going to have the natural log of 1 minus the natural log of 2 from when n equals 1 plus, for when n equals 2, we're going to have the natural log of 2 minus the natural log of 3. When n equals 3, we're going to add on the natural log of 3 minus the natural log of 4. When n equals 4, we're going to have the natural log of 4 minus the natural log of 5. And finally, when we have n equals 5, we're going to have the natural log of 5 minus the natural log of 6. So that's for when n equals 5, right? These are all the terms we have. So now when we look at them, at this, we can kind of start to see a pattern, right? So we can start to see that we have some cancellation happening. What are some of the terms in here that cancel? We have negative ln of 2, and we have natural log of 2. We have negative ln of 3. We have positive natural log of 3. We have a negative natural log of 4 and a positive natural log of 4. We have a negative natural log of 5 and a positive natural log of 5. So we see that really our only two terms that are left in this series is our first term and our negative last term, right? So now that we kind of see a pattern, let's try to write out this pattern for some arbitrary number, some just number that we throw out there. So let's let n equal k. So when n equals k, what we're going to have left, we're going to have our first term, which is going to be the natural log of 1, right? So that's left. So now we have to look at this term. If we're to write this term in terms of k, what would it be? So here's our first term, right? Our second, our third, our fourth, and our fifth. So this is our last term. This guy is our kth term, right? And within our kth term, this second part here is what's left. So onto this guy, we're going to subtract, right, because he's negative, subtract our ln of our k, right? So when we plug in k into this whole term, right, here we plugged in 5. So we plugged in 5 here, we added the 1 to get the natural log of 6, right? So here, we know we don't need this term because he's going to cancel out. So if we plug in our k here, we're going to get negative natural log of k plus 1. So now that we have our general rule, we can actually start to do our work to determine whether or not this series is convergent or divergent. So let me just clear some room here. Okay. So in order to determine whether or not the series is convergent or divergent, what we have to do is we have to take the limit of this. So we're going to take of this new rule that we have. So we're going to do the limit as k approaches infinity of the limit, or the natural log of 1 minus the natural log of k plus 1. So what we do is we plug in infinity, do the limit, right, we're going to have the natural log of 1 minus the natural log of infinity plus 1, which is the same thing as 1 minus the natural log of infinity. So what happens? We know that the natural log of 1 is 0, and we know that the natural log of infinity is infinity, because if you kind of look at a graph of the natural log, right, it kind of looks like this, and he's going to go on forever and ever and ever into infinity. So what we're left with is just negative infinity, which means that this series is divergent.